The condition for liquid and vapor phases fluid to be in equilibrium is given by the Clausius-Scalapron equation. The vapor pressure, the volume, where Vp is the volume per particle in vapor phase and Q1 is the latent heat. Now, Q1 may be taken to be a constant. If the vapor obeys ideal gas equation, now which of the following plots is right? We are asked. So, this is the Clausius-Scalapron equation. QL is the latent heat and vapor pressure, volume of the vapor pressure, Vp to T. Now we are told that the vapor volume of the vapor pressure obeys the ideal gas equation. So from this we can write V. So this we can substitute into this equation and we rearrange this equation. We rearrange this equation and integrate it by the method of separation of variables. So just substitute this and rearrange this equation to get this form. So dP by P is equal to dTQL by RT square. So notice here this just can be, so if you integrate on both sides, so if you integrate on both sides, what you would get is, this is just ln of P, right? So ln of P, and right hand side QL and R are constants. So just integrate dt by T square. So what you get is QL and R are constants, they get pulled out the integration, and then the remaining we get minus 1 by T plus of course the integration constant C. Now notice what happens. Let's just discuss this equation so that we have a plot. We can discuss what the plot between ln of P and temperature would look like. So when T goes to infinity, what happens in this equation is ln of P becomes a constant, right? Because this term, when this goes to infinity, this term will become 0 and what remains here is only a constant. So ln of B become a constant. And when T is going to 0, ln of P will progress to infinity, minus infinity. Okay, so it will asymptotically go to infinity, minus infinity. So therefore the right graph for this equation is given by A. Okay, so as T is going to 0, ln of P is going to minus infinity.